welcome back to another version of Develop, Integrate, and Sustain TV, keeping it simple. Today we're going to talk a little bit about virtual data and exactly how we take virtual data from a disparate environment and make it all sensible. The end game, of course, is represented here at this screen. Take legacy databases, spreadsheets, flat files, XML files, databases, and have them all produce an application or data that's needed by an application. In this example, we took information from the spreadsheets here, moved them down into some sort of a bar graph here, and took some information from flat files and pasted that text in there. So how do we do this automated in a large enterprise? Well, let's take a look at how we take data availability from multiple sources. So this chart here represents multiple data sources as seen before. Here we have XML or flat files, legacy data, spreadsheet data, databases, and then we have emerging business needs. So sometimes in environments you have large data infrastructures that really are more complex to get into and add new features to. So this enables us to take new features and put it on here and have that all represented at a centralized data layer. So let's go over that in a little more detail. Here we have our legacy data layer here that exists, and it supplies and has relationships to this virtual data layer here. It represents everything that is here. In addition to representing everything that is here, when new business needs come up, and let's say we need to put on a new database, we can simply add new data sources here, add them into the network, into the infrastructure of this virtual data. Now we see not only our legacy data represented here, but we also see our new business requirements represented here as well. Once we do this, we have to be mindful of performance in the environment. The optimal way to meet this challenge is to provide RAM-based servers. There are several data layer services that allow you to move the data from the database tier into the application or web-based tier. Several of the solutions handle all of the transactions built right into local memory. Some great examples of that are Facebook and Twitter, where most of their work is done inside of RAM and never committed to disk. This works in conjunction to provide the end user the performance that they need. If you have to depend on a disparate data type within your environment where you have many legacy data sources, and this is a real problem and will continue to be a problem as we increase our use and dependency upon data, these data sources will become real. And so we have to figure out a way to intelligently add all of this information together in a centralized view, and then with that centralized view be able to pipe it into a performance-driven data infrastructure that allows us to take advantage of the relationships that this centralized access to these data sources offers, and then allow us to move things into a data layer that is RAM-based, that allows our users to have the fastest performance that we need to provide them with their needs. Well, thank you very much for joining us today for this brief introduction to virtual data. My name is Jeffrey.L.Lush. Please contact me here at Jeffrey.L.Lush@gmail.com or give me a telephone call. Thank you and have a great day.